So this brings up a theory of peak oil. Well, it's a limited resource. We're eventually going to run out of this, right? So the theory of peak oil came about back in the 1950s from a guy named M. King Huber, who predicted statistically that the United States would hit peak oil sometime around 1970. He predicted this way back here in 1956. He predicted that we would hit peak oil something in 1970, and that we would hit that at about 10 million barrels per day. And that's exactly what we came. We came up to just under 10 million barrels per day in 1970, and then that trail started down. Two important events happened. One was the Arab oil embargo in the mid-70s. That spiked the price of oil, right? Started us looking for new sources of it. We found the North Shore of Alaska, Prudhoe Bay. That increased it for a while, then it went back again. The other really significant event came about in 2007. In 2007, the price of oil briefly spiked to $150 a barrel, and it's seldomly gone below $100 a barrel since then. That allowed this technology called fracking to take off, right? It's not new technology, it's 50-year-old technology. What allowed it to be successful the way you see it today is that $100 a barrel you can afford to do it, right? But that's not going to go on forever, and I'll show you a little bit of evidence about that, okay? But what I see in the papers and what I'm really quite curious about is this idea that people have put out that fracking is somehow going to make us energy independent again. In fact, I saw one prediction from this guy right here, Mark Perry. So he's an economist at the University of Michigan, and he's also part of the American Enterprise Institute. And then here's another guy, Arthur Berman, who happens to be a petroleum geologist. And so here's two guys who took the exact same data, right? The source, the Energy Information Administration. So that's the Department of Energy's, factual. These are things. So he took this, and here's his plot of this. So here's Mark Perry's plot of this, right? And what he plotted was petroleum production, the U.S., Saudi Arabia, and Europe. Okay? And what he shows here is that, Europe's on its way down, and here's Saudi Arabia, and here's the United States. Okay? And we passed Saudi Arabia, right? So this is the guy who said, based upon this projection, I'm going to project that we're going to be energy independent, and we'll be exporting oil by 2018, right, in 5 years. And this got picked up by the press. Now, people instantly came out and said, hey, wait a minute, you have us up here at 12 million barrels per day, and our real number is about 6.4. Well, how did you get this? Well, his petroleum turned out to count every single liquid fuel we made, including the 13.9 billion gallons of corn ethanol. He just added that in too. And he added liquid fuels from fracking gas and everything he could find, right? So you can say, well, he skewed it, but at any rate, he projected this, and people said, oh, that's fantastic. We're going to have oil that's going to go on forever. But here's our real production, right? Here's how much petroleum we really produce. And yes, fracking has increased it up to there, but here's our consumption. We're still off by 9 million barrels per day, with no possibility to get there. And the Department of Energy doesn't think we're going to get there. Here's their projections. Here's consumption. Here's production. They say in 2035, we're still going to have a gap of 36%. But the one good news is that they also projected here, what's our energy use per capita? So here's our energy efficiency in 2005 dollars. It's gone down since 1980, which means we're getting much more efficient at using energy. And here's our actual energy use per capita. It started to go down in 2010, mainly because the price of oil got so high, we decided to become more efficient. Okay? But here's why fracking isn't going to last forever and why it is certainly not going to give us energy independence. So this is the average production from shale gas well, right? This happens to be fracking gas wells, and these things drop so that they are only productive for about 3 years, right? So this enormous bolus of natural gas that we have now will be gone in the next 2 years. And the price of natural gas will go back up again to $7 or $8 a million BTU, and then we'll start fracking again. We're not fracking for this now. We've changed fracking to oil because the price of oil is $106, $103 a barrel today. But the overall field production, here's fracking wells and oil wells, and this is a very interesting analysis that this guy right here, J. David Baker, did. What he did was he said, well, the problem is that the number of wells that are going in is going in exponential. We spent last year $186 billion in oil exploration in the United States, the largest number by $25 billion in our history. Okay? We did that because oil is $107 a barrel. So it's very difficult when you're putting on an enormous number of new wells to tell how long they really last. So what he did was he simply picked a point the end of 2011, and he said every well that has been drilled to that point, I'm just going to keep that stable. I'm not going to count all the new ones, and then I'm going to count productivity coming out of those existing wells. And that's how fast the productivity drops. That tells you what fracking gives you is a 2 or 3 year timeline on a well. A traditional well lasts 20 years. That's why there's no possibility that fracking is going to save us. But this is the picture that just amazes me. Okay? This is a picture of North America at night. And I think all of you will recognize, oh, here's New York, here's Dallas, here's Los Angeles and San Diego, San Francisco. What is that? Right? That is North Dakota. Okay? Here's another one right down here, right? That's the Eagleford Shale. So what are those? Here's a close-up of that. These are the number of wells drilled in the North Dakota Bakken Shale. Okay? What these are is this is the gas that is being flared off those at night. All right? Now, some people view this and say, what a great thing. America is solving their energy problem by drilling thousands of wells. Personally, I think what this tells you is this is a serious addiction. Right? This isn't Charlie Sheen addiction. This is Lindsay Lohan addiction. This is the kind of addiction where we need intervention. Okay? So here's the actual increase. So how much did we really increase? So what did all this really do for us, right? So in 2010, we had stores of about 25.2 billion barrels. Extensions, that's how much you get to expand it because the price has gone up so you can do more expensive drilling. That's what really came up. New field discoveries, almost nothing. Here's how much we actually used. So the net gain of that was about 3.8 billion barrels. That's pretty good. 3.8 billion barrels, while we have 29 billion barrels, that's enormous. That must last us for about 4 years. We consume 7 billion barrels of petroleum per year. All of fracking gained us about 7 months of oil reserve. Okay, so here's just another way to look at that. This is our oil production over the last 10,000 years. And what this really should say is this is cheap oil production over the last 10,000 years, right? Because at $107 a barrel, you no longer have cheap oil. So that number actually is our production of that is down to zero. But let me just finish with a couple of different thoughts, because our problem is not $4 a gallon gasoline. Our problem is that when we think about energy, we need to think about food. These things are interchangeable, right? They're interchangeable because we take about 40% of our corn crop and we turn that into ethanol and we blend that with gasoline, okay? But we also take petroleum and we turn that back into food. We mainly do that by photosynthesis, okay? We do that by agriculture. It takes an enormous amount of energy to run agriculture, right? As I said, we can turn some of our corn into ethanol. We blend that with our cars. But in fact, both of these things are just two different forms of chemical energy, all right? So why is that a problem? That's a problem because we've had enormous increases in yield over the last 50 years, brought about by industrial agriculture. But how did we achieve those? We didn't achieve those by increasing the number of farmers or the amount of land we used for farming. We did that by the number of tractors, by the amount of fertilizer, and the amount of energy we put in. So fossil fuel, what we did was we put in enormous amounts of fossil fuel. We had enormous increases in yield. Here's the increase in yield. This happens to be wheat in India from 1960 to 2009, but this would have been true for any of the crops we looked at. Enormous increases in yield, all right? But enormous increases in yield that came at the price of enormous increase in energy. And in fact, if you plot the two, so world food prices, so here is the average oil price in red, here's the average food price in blue, and you can see they track one on top of another. So why that's a problem is this right here. So what this is that same slide now of cheap oil production, and overlaid on top of that is world population, right? That's in the red. And here we are right here. So what we did was we took cheap, inexpensive fossil fuel, we turned that into cheap food, and that allowed our population to go above 7 billion people. So the problem now is, what do you do when you have $100 a barrel oil, because now you no longer have cheap food, all right? And we are actually seeing those problems today. This is not some abstract thing that is going to happen in the future. This is what the Arab Spring is. What the Arab Spring is, it morphed into a democracy riot, but it started as food riots. Because when you have $100 a barrel oil, you have $12 a bushel wheat. And when you have $12 a bushel wheat, About 2.5 billion people on the planet barely get by. 1 billion people no longer get by. So this is the real issue in energy. How on earth can we get food back to being affordable for that bottom billion people, right? And that's what we're going to talk about over the next 4 weeks. We're going to talk about the environmental consequences of this, but we're also going to talk about the economics and the sustainability of this. Because this is really the problem we have to address. How do we have a limited resource like energy, whether that's fossil fuel, whether it's sustainable energy, how do we equitably distribute those throughout the planet? That is the real challenge that we face. We'll actually do fine in this country. We can afford $4 a gallon gasoline. We could afford $6 a gallon gasoline. And we could probably afford $14 a bushel wheat, but large parts of the world can't. Okay? So I'm going to leave you, though, with one optimistic thing, and then I'm going to let the next two scientists tell you about many opportunities we have. But here's the last good news, okay? The world consumes 16 terawatts of energy every year. Today, 85% of that comes from fossil fuel. The good news is that the sun provides 86,000 terawatts of energy every year. So 6,000 times the amount of energy that we need to run the planet for all food, for all transportation, for all water pumping, for all of that. 6,000 times that amount of energy comes from the sun. So we simply have to figure out the way that we take that form of energy, and we don't disobey the laws of thermodynamics, but convert that into the forms of energy we need, which are food and transportation fuels and electricity. And I will end it right there, and thank you very much for your attention.